Hi, my name is Jeff Perry, and I'm the manager of the WebBench team at Texas Instruments. In this presentation, I'm going to talk about WebBench, Power, and FPGA Architect. Power Architect, FPGA Architect, and Processor Architect are tools that are built on top of the WebBench Visualizer technology and the WebBench Power Designer tool. Basically allows you to design entire power supply systems. Increasingly, challenging designs such as this one here are encountered every day by power supply designers. This board, for example, has 9 loads and 5 different voltages. And so the question arises that even with a tool like WebBench Power Designer, it takes a little while to design something like this if you're going to approach this on a supply-by-supply basis. So we developed a tool that allows you to instantly input these requirements for your loads and then design the entire power tree in one shot. Why do designers use reference design so frequently for complex things like FPGAs? Well, I think the answer to that comes in the fact that it's very complicated power requirements. For example, some of the parts have 20 or 30 pages of power details mixed in amongst over 400 pages of other guidelines, and or maybe it's 15 pages mixed into over 2,000 pages in a document. And so even for experienced power supply designers, configuring the power for parts like these can be difficult. Each specification includes other requirements aside from just voltages and currents. They also include ripple limitations, frequency limitations, accuracy requirements. There may be a soft start required, supply isolation required, pin-specific limitations for voltages and currents, and even things like sequencing. And then in addition to that, complete systems have additional loads beyond just the FPGA, adding more to the complexity, and another reason not to be able to use a reference design. So even for an experienced power supply designer, could they do this in minutes and do it with confidence? Maybe not. And so this is why we created WebBench Power Architect. To start out with, in WebBench Power Architect, you would start out by opening up WebBench and going to the FPGA Power Architect tab. On the top row there, you have a button that allows you to select the FPGA microprocessor and/or microprocessor. And there are over 300 different FPGAs and microprocessors installed in the WebBench tool at this point. So you'd simply select those from a list. On the right-hand side, it gives you the listing of the different loads that are required to be powered for that FPGA or processor. And you can individually select or deselect the loads on this screen, and also select the different voltage options that are allowed. Once you've done that, just click on the Add Loads button, and that will take you into the next page, which allows you to review your inputs to the tool. And so this is where you can look at things like what the specification is for maximum voltage ripple, whether the supply needs to be isolated, whether it requires soft start, whether post-supply filters are required, whether LDO is preferred, also whether sequencing is required, and also grouping of loads. In addition, you can also add your own additional loads by just clicking on the little Add Loads button up here in the upper right corner. When you're done configuring all of your loads, just click on the green button to go to the next step. Now WebBench generates a variety of different power trees that would satisfy your needs. And this is shown in a graphical representation. On the x-axis you have the system efficiency for the entire system, and on the y-axis you have the total BOM footprint size for all the power supplies, and then the bubble size here is the relative system cost. In the upper left we have the WebBench Optimizer dial, and as you turn this dial you can optimize this entire system for high efficiency, small footprint, or low cost. And this will change the switching frequency and optimize individual designs to achieve the whole system goal. How does WebBench Power Architect work? Well, here's an example of a typical power tree. On the left side you have your input voltage here, which is a 48 volt nominal. On the right side you have your loads, and in the middle WebBench has selected the power supplies for you. Now for each one of these power supplies, WebBench can select among dozens of different options, and depending on where you set your optimization knob to, it's going to pick the topmost candidate based on your desired performance. And then it also does that for each supply in the power tree. And so this ends up running literally thousands or multiple thousands of different design candidates trying to pick the best one for your design goals. In addition, WebBench will look at different power tree architectures. What does this mean? Well, there's different ways to hook up 48 volts and drop that down to the low voltages that we need. For example, you can go from 48 volts with a supply connected directly to your loads, and that's what we'd call a no intermediate rail option. And in this graph you can see here we've plotted the frequency again, or I should say the footprint on the y-axis and the efficiency on the x-axis, and that's not a particularly good solution. It's got low efficiency and high footprint. Here's one where we've dropped 48 volts down to 12 volts intermediate rail, and then we've got other supplies coming off of that 12 volt rail. That's improved our efficiency and footprint a bit, and that one turned out to be the lowest cost. We then furthermore can try things like a 23 volt intermediate rail or multiple different intermediate rails, and in this case the highest efficiency and lowest footprint turned out to be one with a 12 volt intermediate rail and a 5 volt intermediate rail. And this can change depending on your set of loads, and so it's important here to evaluate these different scenarios for your given case. After you've selected your desired architecture, you can then go in and look at some of the details about the supplies. On this screen over here we can see as you click on a supply, it'll give you the detail over on the right where you've got some schematics and also details about the voltages and the loads that are attached to that. In the upper right we have pie charts which tell you the relative contribution of that supply to the entire picture of power dissipation, BOM cost, and footprint. And so if you want to be able to sub-optimize these things, you can say, you know, this is the design that's contributing the most to my cost. I'd actually like to pick a different regulator. And so if you click on one of these, it will actually give you the option to choose a different regulator in the list. When you're done sub-optimizing your power tree, you can click on the Go button to create the entire project. And this will create all of the WebBench designs for you and save them in your personal account. To summarize, WebBench Power Architect allows you to quickly create multiple load power systems using popular FPGAs and processors, and also using your own individual specialized load requirements. You can compare different power trees using graphical tools and optimize a system for small footprint, high efficiency, or low cost. It automatically rates the entire system BOM in the schematics for you, and then you can run simulations to evaluate dynamic system behavior. You can also generate a PDF project report documenting the entire design. The goal of this, of course, is to save you time in your design. I encourage you to try WebBench tools yourself by going to webbench.ti.com, and I want to thank you for joining us today.